All right, this is chapter 9.1, right triangle trigonometry. I just love trigonometry. It's so much fun. The essential question, how can you find a trigonometric function of an acute angle theta? Okay, consider one of the acute angles theta of a right triangle. Okay, obviously there are two because of the triangle sum theorem. If we had an obtuse angle, we can't have a 90-degree angle because something more than 90 plus 90 is more than 180, and the triangle sum theorem says that the sum of the angles have to add up to 180. So the two angles in a right triangle both are acute. So one of these acute angles, theta, of a right triangle, we're going to consider one of the angles. So here it is. That's called a reference angle. Consider one of the acute angles, theta, of a right triangle. Ratios of a right triangle side lengths are used to define the six trigonometric functions as shown. So sine of theta is the opposite over the hypotenuse. So here's theta, here's the opposite side, and here's hypotenuse is always opposite the 90-degree angle. So opposite over hypotenuse. Cosine is adjacent. So it's the side that's forming theta along with the hypotenuse, adjacent over hypotenuse. Okay, and then we have tangent. Tangent's opposite over adjacent. Okay, and then cotangent are just adjacent over opposite. Well, what does that look like? Cotangent is the inverse of tangent. Secant is adjacent over hypotenuse, so it's the inverse of cosine. And cosecant is the inverse of sine, hypotenuse over opposite. Okay, so really you just need to know the three, sine, cosine, and tangent, and then flip them over, and you have cotangent, secant, and cosecant. So what you will learn is how to evaluate trigonometric functions of acute angles, find unknown side lengths and angle measures of right triangles, and use trigonometric functions to solve real-life problems. So let's take a look at these. Okay, so before we jump into the first example, let's look at some information that was in the text. It says six trigonometric functions. Consider the right triangle that has an acute angle theta right here, the Greek letter theta. The three sides of the triangle are hypotenuse, opposite side, and adjacent side to theta. Ratios of a right triangle side lengths are used to define the six trigonometric functions of sine, cosine, tangent, cosecant, secant, and cotangent. These six functions are abbreviated by sin, cos, tan, CSC is cosecant, and SEC is secant, and COT is cotangent, respectively. So right triangle definitions of trigonometric functions. Let theta be an acute angle of a right triangle. The six trigonometric functions of theta are defined as shown, which I've already said in the previous page. And we reduce that to OPP over HYP and ADJ over HYP and so on. So we just use abbreviations OPP, ADJ, and HYP to represent the side lengths of the right triangle. Note that the ratios in the second row are reciprocals of the first row. So the cosecant is the inverse of sine, secant is the inverse of cosine, and cotangent is the inverse of tangent. Now, let's look at example one. Okay, so here is a triangle. Theta is up here. It says evaluate the trigonometric functions. Evaluate the six trig functions of the angle theta. So what I'm going to do is say sine of theta equals, I'm going to put a line, cosine of theta equals, and tangent of theta equals. And let me change colors for the inverses. Okay, so think of cosine. A lot of students confuse the inverse name for sine and cosine. So let's look at cosine first. So what you do is take cosine and write it backwards. It looked like SOC, but then just change the O to an E. And that's just the easiest way to remember which is which. So now that I've eliminated secant theta from the mix, then cosecant by elimination must be sine, and cotangent, COT, is obvious because it's got the T in it. Okay, hopefully that makes sense to you. Cosine backwards, change the O to E, secant. All right, so sine. So I've made all these fractions. So sine is opposite over hypotenuse. Let me just do this real quick. Let me move these over further. Whoops. That guy got exploded. Okay, let's move those over a little bit. And I'm going to write sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangents opposite over adjacent. And I'm going to do this just until we remember what they are. But once we memorize them, you don't have to do this anymore. So sine is opposite, which is 12, over the hypotenuse. Uh-oh, I don't know the hypotenuse. So guess what we need to do? We have to come off to the side here and do the Pythagorean theorem and find the hypotenuse. So c squared equals a squared plus b squared. And the hypotenuse is the c squared. So c squared equals a squared plus 12 squared. And it does not matter which is a and which is b, because addition is commutative. So then c squared equals 25 plus 144. And therefore c squared equals 169 when you add 25 and 44. And then I'm going to take the square root of both sides. And taking the square root of c squared, I get c. And the square root of 169 is 13. So now I know my hypotenuse is 13. All right, so now I can answer adjacent over hypotenuse and all those. So opposite over hypotenuse should be 12 over my hypotenuse that I just found, which is 13. My adjacent is next to the theta, which is 5. So this is 5 over 13. And opposite is 12 over adjacent 5. So this is 12 over 5. Okay, so there is sine, there is cosine, and there is tangent represented as a fraction. Cosecant is the inverse of sine. Just flip it. 13, 12. 5, 13, 13 over 5. 12 over 5 is now 5 over 12. Okay, we're done. That is how you find all 6 trigonometric functions of theta with a triangle when you don't know one of the sides. Now you should be able to do number 6, 8, and 10 in your exercises. Okay, so here's example 2, evaluating trigonometric functions. Okay, so it says in a right triangle, theta is an acute angle and the sine of theta is 4/7. Evaluate the other 5 trigonometric functions of theta. It is always a good idea to draw a diagram. So I'm going to do that. So here's my diagram. Here is a right angle, a right triangle. So this is my 90-degree angle here. So this is C. Let me put the names of the sides inside. So this is C. And if this was angle A, this is angle B, and this is angle C, then this would be side A, lowercase opposite, and B opposite, side length is B. All right, so it says here sine of theta, which is opposite over hypotenuse. Okay, that's the first thing. Right here, we were given sine theta. So opposite sine of theta. Oops. Sine of theta equals opposite over hypotenuse. And they gave us 4/7. So that tells us the opposite is 4. So opposite, and let me mark this angle here as theta. Opposite is 4. Hypotenuse is 7. Let me change those colors. Everything's red. It doesn't stand out. So opposite 4, hypotenuse 7. So again, I don't know the other side. So off to the side here, I'm going to say c squared equals a squared plus b squared. My hypotenuse is always the longest side, and I have to be careful to put that by itself. And 4 squared plus b squared. 49 equals 16 plus b squared. Subtract 16 from both sides, and I get b squared equals 3. Okay, take the square root of both sides, and I get b equals the square root of 33. And I always check to see if I can reduce that. Well, 3 times 11 is 33. 11's prime, 3's prime, so I cannot simplify the square root of 33, so I'm going to leave it just as that. Okay, so there is my b. So I'm going to put it over here, square root of 33. So now I know all 3 sides. So now what do? Well, I write sine of theta equals, I'm not going to do, well, yes, I am, opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. Okay. And let me do the inverses in a different color. And remember what the rule I said, the little trick. So I'm going to put secant over here and cosine backwards, change the O to E. That reminds me that cosecant is the inverse of sine, and I need a theta. So let me fix that. Cosecant theta equals secant theta equals, and cotangent theta equals. Okay. And so this is going to be hypotenuse over opposite. This is hypotenuse over adjacent. And this is adjacent over opposite. Okay. Adjacent over opposite. All right, so now I'm going to substitute in my givens. So sine of theta was opposite over hypotenuse, which is 4/7. And see that? They gave it to us, but there it is. Adjacent is square root of 33/7. And opposite over adjacent is this. But this is a problem. We do not want to leave the denominator as an irrational number. So we want to rationalize the denominator. So sidebar over here, 4 over the square root of 33, and multiply the top and bottom by the square root of 33. And I get on top 4 square root 33, and on the bottom is just simply 33, because anything times itself, the radical cancels, and we get the radicand when they're the same. So my answer is not 4 over root 33, so I'm going to erase that. I'm going to put 4 root 33 over 33. Okay, hopefully that makes sense to you. Just rationalizing the denominator like we've done before. Okay, so now we have hypotenuse. Now I'm just doing the inverses of these. So I don't even look at the diagram anymore. I just put 7/4 and 7 over root 33. And I need to change that. So again, off to the side over here, 7 over the square root of 33 times the square root of 33 over the square root of 33 equals 7 square root 33 over 33. So this is 7 square root 33 over 33. Okay, there's the secant. And then finally, we get the inverse of this. Now, here it is right here originally. I do not need to flip this over and then do that again. Just go to this. 4 over root 33, flip it over. Now it's the square root of 33 over 4. Or you could look at the diagram for this. So cotangent's adjacent over hypotenuse. Okay, so just work harder instead of, or why work harder when you can work smarter type thing. All right, so just go back to the other one and look at the inverse or look at the diagram. So there we go. There are our other 5 trigonometric functions knowing sine of theta is 4/7. Okay, so now you should be able to do problem numbers 13 and 18 in the exercises. Okay, another core concept. The angles 30 degrees, 45 degrees, and 60 degrees occur frequently in trig. You can use the trigonometric values for these angles to find unknown side lengths in special right triangles. So there's the highlighter right there, special right triangles. Okay, blast from the past, geometry. So trigonometric values for special angles. The table gives you values of the 6 trigonometric functions for the angles 30, 45, and 60. You can obtain these values from the triangles shown. So where did these triangles come from? Well, I'm going to do a quick review here really quick. And I'm just going to zip along here. I am going to cut an equilateral triangle in half. Okay, so that's where the special right triangle comes from. So if this was 2x, and this is 2x, and this side is 2x, now watch what I'm going to do. I'm going to cut it in half. So I'm going to take and draw a line right down the center. I'm going to cut it in half, and now I'm going to focus on one of these sides. So this whole side is 2x. So I'm going to delete that. And so if the whole thing is 2x and I cut it in half, this side, this is x, and this is x from this point over. And these are right angles. So now just focus on this triangle right here. I have x, I have 2x, and to find this side, I'd say c squared equals a squared plus b squared, and my c is my hypotenuse, so 2x quantity squared equals, and I don't know the height, so let's just leave that a squared plus x squared. This is my base right here. So do the Pythagorean theorem. Don't forget to distribute. You're going to get 4x squared equals a squared plus x squared. Subtract x squared from both sides. I know I'm speaking fast, but you can always slow the speed of the video. This is also review. That's why I'm going quickly. So I get 3x squared equals a squared. Take the square root of both sides, and I get a equals, and I can't take the square root of 3, but the square root of x squared is x. Okay, and that's where this comes from. So then if x was 1 right here, that's my x, then I get the square root of 3 for my height, because this is x square root 3. And if x is 1, then this x is 1, and this x is 1, and 2 times 1 is 2. So I get 2, 1 square root 3, and 1. 2, 1, and 1 square root 3 is just simply root 3. Okay, real quick there. So that's that. Let me get rid of these. And now let's focus on a square. So a square, what do we know about the side lengths of a square? Well, they're all the same. So this is x, this is x, this is x, this is x. What else do we know? We know the angles are 90 degrees. So if I do this and then I cut it in half, again, I'm going to cut it in half. And let me use purple this time again. And I'm going to cut it diagonally like so. Well, if I cut it in half, this is no longer 90 degrees. I cut it in half. So they're what? They're what? They're what? They're what? They're 45 degrees. 45 degrees. I cut them in half. 45 degrees. 45 degrees. I know now I'm focusing on the triangle and ignoring the other side. So I have a 45, 45, 90 triangle, as you see here. And I know both sides are the same. How do I find the other side? Well, it's c squared equals a squared plus b squared. I don't know my c in this case, but a is x and b is not b. B is x. So I'm going to say x squared plus x squared. So c squared equals 2x squared. Take the square root, and c equals, well, the square root of x squared is x. I can't take the square root of 2, so I leave it like that. So this side is x square root 2. So then if x equals 1, and x equals 1, and this x is a 1, then I get 1 root 2, which is just root 2. So we have 1, 1, square root 2. All right, mind equals blown. So now that I've done that, all they've done here is taken the sine of 30 degrees. Well, where is 30? I didn't mark it. Here's 30 degrees. Here's 60 degrees, because these were all 60-degree angles. I forgot to say that. It was an equilateral or equiangular triangle. So I cut it in half. So sine of 30, opposite 1, adjacent 2. 1, or hypotenuse 2, 1/2. Okay? Cosine, adjacent, square root of 3 over 2. And there it is. Okay, and that's where these all come from. All right, so then tangent, I'm looking over here now, tangent of 30 would be adjacent over, opposite over adjacent, opposite over adjacent, which is 1 over square root 3, and we have to rationalize the denominator, and it's 3 root 3. So you just go through all these on your own if you wish, but they all just come from our trig ratios. And that's where that table comes from. Once you use this enough, you do actually memorize it without realizing. Okay, but I do not recommend just trying to memorize them. Think of the diagram, get the values from doing the process. Okay, here's example 3, finding an unknown side length. Find the value of x for the right triangle. So here we have a 30-degree angle. We have a 60-degree angle. So it's a 30, 60, 90 triangle. Okay, and the hypotenuse is 8. Okay, so we don't know the adjacent and we know the hypotenuse. So you always use the trig ratio of the two values that you're going to use. So this is going to be adjacent over hypotenuse. So I'm going to write that ADJ, AB, ADJ over h, y, p. Okay, from the 30-degree angle. And what is adjacent over hypotenuse? It is cosine. So you say cosine of theta equals adjacent over hypotenuse. The first thing you want to do is come up with your formula. Then substitute in your givens. Well, what is the angle measure? Well, it's 30. That's called the reference angle. So cosine of 30 degrees equals adjacent over hypotenuse. So you write the rule, you substitute the givens, and you simplify and solve. So how do I get rid of this? I get x by itself by multiplying both sides by 8. Okay. So then I would get x equals 8 cosine 30 degrees. Well, I need to use a calculator to calculate this. So that's one way we can do it, but there's a different way to do it. So if we have a 30, 60, 90 triangle, if we know the ratio setup, this is, now I'm going to do it in, let me see, what color could I do that in? I'll do it in black. So this side would have been our x, and this side would have been our 2x. Remember our right equilateral triangle I cut in half? So it's x, x, 2x. So 2x, 2x, 2x. That's where that came from. And if you just picture that, you can figure this out. So without going back and looking. So I know if this side is x, this is 2x, and this is x square root 3. Okay. So now I'm going to use this again. So it's going to be cosine of theta equals ADJ over HYP. Substitute my givens. Cosine 30 degrees equals, well, what is the adjacent to 30? Or we could look up the cosine of 30. So how should I do this? Trying to figure this out. You could say, well, the cosine of 30 is x square root 3 over the hypotenuse 2x. Oh, and look what happens. The x's cancel. So my answer is the square root of 3 over 2. Okay, so there's the cosine of 30. So the cosine of 30 is the square root of 3 over 2. And if I go back and check my table now, cosine of 30, square root 3 over 2, that is what it is. That has to equal adjacent over hypotenuse. Okay. And once we do this, then we can cross multiply and say 2x equals 8 square root 3. Divide both sides by 2. 2's cancel. I get x equals the 4 times the square root of 3. So there is my answer in terms of radical. Okay, do not simplify this unless it tells you to. If it says round to the nearest whatever, then you do that. So if I went to my calculator now, just for kicks, see that 8 cosine 30? So if I go in and I put that in, so here's what I'm doing right now. I'm doing this 8 cosine 30. First thing you have to do in your calculator is go to mode and make sure you're in degree mode, not radians. So that's pre-calculus. So if I switch this to degree, and then I go to the calculator and I say 8 cosine 30, I get 6.92820323. Well, if I put the 4 times the square root of 3 in the calculator now, I get the same value. Okay, so the easiest way to do it is to know that the cosine of 30 from the special right triangle is adjacent root 3 over 2. And set it equal to x over 8. Now you should be able to do problem numbers 22, 24, and 26 in your exercises. Okay, example 4 says using a calculator to solve a right triangle. So solve triangle ABC. What do they mean by solve a triangle? I didn't know triangle had a problem. But anyway, I guess this triangle has a problem and we need to fix it. So we have one angle. We have 2 angles. We can get the third angle. So just to find, so I could say, well, the measure of angle A equals 28 degrees. The measure of angle B equals, oops, B. Why did I put a B there? The measure of angle B equals, and the measure of angle C equals 90 degrees. Remember the triangle sum theorem or the acute angles theorem of a right triangle, they're complementary. 90 minus 28 is 62. So 62 plus 28 is 90, plus 90 is 180. So there's the three angle measure. So this is 62 degrees. 62, 28. Okay, so there's one. The other thing we want to do is we want to find the side lengths. So we found the measure of angle B. Now I want to find the length of A, B, and C. Notice A is a capital letter, and across from the angle is the same name, lowercase. Sides are lowercase letters, angles are capitals. So if I said A equals, B equals, and C equals, it means the length of the sides. We already know B is 15, and that's all we know right now. We know B. We don't know A, we don't know C. So I can't do the Pythagorean theorem because I have two unknowns. So I have to use trigonometry. So let's find C first. So here is angle 28, and that is my reference angle. So I know the adjacent. So if I said cosine of theta equals adjacent over hypotenuse, and my theta is 28, then I now know cosine of 28 degrees equals 15 over my C. Okay, so I'm trying to solve for C. So if I'm going to show this once, but there's a shortcut. If I multiply both sides by C, I get C times the cosine of 28 degrees equals 15. But then I want to get C by itself. So I divide by the cosine of 28 degrees, divide by the cosine of 28 degrees, and then I get the C equals 15 over cos 28. All right. Well, there's a shortcut, guys. 15 over cos 28. Watch this. All you have to do is take the numerator. Let's explode that. Let's say ungroup. So take this 1 and this 5, and I'm going to group them so it's just one together. Group the 15. So what I'm going to do, I'm going to group it with this also. Shift here. I'm trying to show something to you. So what I did was multiply both sides by C, and then I divided by cos 28, and then cosine 28 ended up underneath 15 as the answer. But if you see this, if you see cosine 28 equals 15 over C, all you have to do to solve for C is move the 15 over the other side. And now it's the numerator on the other side, and there is what C equals. So I go to my calculator and I say 15 divided by, now before I do that, I'm going to go to mode. Always make sure you are in degrees. I can't stress that enough. Degrees, degrees, degrees. So I have 15 divided by, and I always like to put parentheses just in case, the cosine of 28, and hit enter. And so C is 16.99 roughly. So it's an approximation. So I'm going to change that to an approximately 16.99. It didn't say what to round it to, so I'm just going to leave it as that. So C is approximately 16.99. Now, I could also do another trig ratio here, or I could do the Pythagorean theorem, but this squared, so I could do it that way. So here is the one side. So now all I'd have to do really is hit squared, enter, plus 15 squared. So that's the sum of the two, and take the square root of those. And that would be my A. Okay. So 22.66. Now, that's not right. What happened? I did something wrong. Anyhow, so let's do it the way I was going to do it anyway, but let's just see what I did wrong. I'll get back to that. Oh, it's because it's my C. I didn't subtract. Never mind. All right. So anyway, we have this 28 degrees. We know adjacent. We now know C. Well, so let's do this. Now we could do opposite over that. Or if I don't want to use the decimal, which you probably shouldn't, because it's an approximation. So let's use, with respect to 28, we know opposite and we know adjacent. So that's what I'm going to write. I'm going to write opposite over ADJ. And then I ask myself, what is that? Well, it's tangent. So I'm going to say the tangent of 28 degrees, or the tangent of theta for starters. The tangent of theta equals opposite over adjacent. And then substitute my givens. Tangent 28 equals A over 15. Okay, this time I have my unknown in my numerator, so I don't want to move it over there because then I have A over tan 28. I want A by itself. This time I'm just going to multiply both sides by 15. These cancel, and I get A equals 15 times the tangent of 28. Okay, so then it's going to be an approximation. And I'm going to say 15 tan 28, enter, and I got 7.98. So it's roughly 7.98. Okay, so that's how you find these. Now, what I did wrong in the calculator right here, if I wanted to find the Pythagorean theorem from this, and I didn't know this, it is c squared. So I would take my answer. Let me see where it was. Let me back up. Whoops, clear. Second, enter, second, enter, second, enter, second. There's where I made the error. I added second, enter. So I have 15 divided by cosine 28, and I hit enter. So I get this 16.98888. That's my C. So I square it. Squared, enter. And I get this number. I want to subtract 15 squared. And I get 63.61. Then I take the square root of that. And I should get 7.98, which I did. Okay. So either way you do it, since this is a trig ratio chapter section, you should practice the trig ratios, not the Pythagorean theorem. That's geometry from last year. So anyhow, there is solving a triangle. I found the measure of angle B, and I found side A and side C. Now you should be able to do problem numbers 34, 36, and 38 in your exercise. Okay, example 5, using an indirect measurement. You are hiking near a canyon while standing at A. So you are right here standing at A. Okay. You measure an angle of 90 degrees between B and C. So at the angle A is 90 degrees. You then walk to B and measure an angle of 76 degrees. And the distance you walked was 2 miles. How wide is the canyon between A and C? So you make a 90-degree angle and you find a point. You walk 2 miles. You find that same point and determine that that is a 76-degree angle here. How long is this side right here? So let me just copy this so we can see it. So let me choose a color and a size of a line segment. How about blue? So I'm just going to go like so, and like so. Okay, and I'm just trying to choose these. And I'm going to move them off so we can see it better. So here it is. This is my 90-degree angle. This is, 76 degrees is over here. And I don't care what that is. I need to know that length. This is 2 miles. Okay, so my reference angle, I'm going to highlight that this time, just put a dot. Here's my reference angle right here. With respect to my reference angle, I need to find the opposite, and I know the adjacent. So that's what I write. Hang on, my computer's wacky. So I'm going to put opposite over adjacent. And what is opposite over adjacent? It is tangent. So I write tangent theta equals opposite over adjacent. Now I substitute in my givens. The tangent of 76 degrees equals x over 2. Multiply both sides by 2. I'm going to get x equals 2 times the tangent of 76 degrees. Get my trusty calculator out, turn it on, clear, 2 tan 76. Make sure you're in degree mode, by the way, and hit enter. And so x is approximately 8.02 miles. So the distance from A to C is approximately 8 miles. Okay, so that's how you do that in the real world. And so now you should be able to do problem number 41 in your exercise. Okay, before I do example 6, we have to talk about a term. So it says if you look at a point above you, such as the top of a building, the angle that your line of sight makes with the line parallel to the ground is called the angle of elevation. So if you are standing here, you have to look up to see the top of that building. This angle down here is your angle of elevation, okay? Then it says at the top of the building, the angle between a line parallel. So now we're at the top of the building and we look straight out and then we look straight down. That is your angle of depression. So parallel to your line of sight and then looking down, if you were standing on the roof here, this is your angle of depression. Your angle of elevation from the ground is looking up. So if this is parallel to the ground and you're looking up or down, these are alternate interior angles. And therefore the angle of depression is equal to the angle of elevation because they're alternate interior angles. Okay, and that's why they have the same measure. All right, so now we're going to do the next problem. So let me get this out of the way. Delete all this. Delete. Okay, so now we have example 6, using an angle of elevation. It says a parasailer, there's a parasailer here somewhere, right there. There's a parasailer, is attached to a boat with a rope 72 feet long. So I'm going to draw a triangle because that's what this is going to be. So picture this triangle if it were rotated, okay? And we were over here looking from the side. Here's where it's connected to the boat. Here's the parasailer up here, and here's the water down here, okay? So the parasailer's up here, and here's the boat. Okay, so I'm going to call this B for boat and P for parasailer. And I don't know, I'll call this A. Or I could call that C and put, no, I don't. This is always going to be C. Let me call it C because that's the right angle. Okay, a parasailer's attached to a boat with a rope 72 feet long. The rope is our hypotenuse, 72 feet. The angle of elevation from the boat to the parasailer, which is down here, is 28 degrees. Remember, angle of elevation, you have to look up. Say, elevation. Estimate the parasailer's height above the boat. So how far is this height? Of course, the boat's on the water. So really it should have said estimate the parasailer's height above the water. But the reason I said that's because it's attached to the boat and the water's actually down here a little bit. So, okay, that makes sense. So here we have it. This is what is called our angle of our reference angle, 28 degrees. What do I know and what do I want to know? I want to know opposite and I know hypotenuse. So I want the sine. So the sine of theta equals opposite over hypotenuse. First thing you do, write the formula. Second thing, substitute the givens. Sine 28 degrees equals opposite over hypotenuse. Multiply both sides by 72. Piece of cake cancels. X equals 72 times the sine of 28 degrees. So X is going to be an approximation. I get my trusty calculator, turn it on, clear it. 72 sine 28, enter. And I got approximately 33.8. So this parasailer's approximately 33.8 feet above the boat. Okay, so that's how we use angle of elevation and trig to find distances. So now you should be able to do problem number 43 in your exercises. Okay, that brings us to the end of chapter 9.1. Hopefully you have a deep understanding now of sine, cosine, tangent, cosecant, secant, cotangent. And now you should be able to do problem number 6 through 43 here. Thanks for watching and have a great day.